Dear students, we are solving problems under the topic inverse Laplace transform using partial fractions. So now here the question is, find the inverse Laplace transform of 1 divided by s plus 1 multiplied with s squared plus 2s plus 2. So we have to first resolve this into partial fractions, for which we have to check whether are we able to factorize the terms given in the denominator. So already s plus 1 is a factor, but for this can we use the Hill method in order to find the factors? But we observe that there are no perfect roots for this. So we have to have this term as it is and resolve it whenever we have a square in the denominator. So how to resolve it? That method we have to use here. That is, we will be separating this as a by s plus 1 and this as, because we have a square over here, this will be separated as bs plus c in the numerator will be taken. So as we do the problem, you will understand it better. So let us start to solve this problem. So first we will write whatever is there inside the bracket. So I have taken and written it here. So this can be written as a divided by the first term is s plus 1 plus bs plus c. Since we have the square over here, we have to write bs plus c divided by s squared plus 2s plus 2. Now on the right, if you take the LCM, we will be having s plus 1 multiplied with s squared plus 2s plus 2. And in the numerator, a will be multiplied with, you multiply a with this term. So s squared plus 2s plus 2 plus this bs plus c has to be multiplied with s plus 1. So this is what we get on the right. On the left, we have the terms as it is. So s plus 1 in the denominator and s squared plus 2s plus 2. Now if we compare, if you see on both the sides, s plus 1 can be cancelled and this also has to be cancelled, and so we get it as 1 is equal to a multiplied with s squared plus 2s plus 2 and multiplied with you have a plus sign over here, so plus bs plus c multiplied with s plus 1. So here there is a plus. Okay. So now we have to do this very carefully. We have to find the values of a, b and c. So let us solve it now. I have just taken and written it very clearly. Now we have to put values for s. So put s is equal to, first we will put s is equal to minus 1. So that if you put minus 1, this whole term will become 0 and easily we can find the value of a, because minus 1 plus 1 is 0. So put s is equal to minus 1. On the left you have only 1. So 1 is equal to a multiplied with minus 1 square is 1 minus 2 into minus 1, so which is minus 2 and then plus 2, and this full term becomes 0 because minus 1 plus 1 is 0. So these two terms, minus 2 plus 2 gets cancelled and a into 1 is a, and so we get the value of a to be equal to 1 from this. Next we can put the value of s to be equal to 0, so that this will vanish, and c easily we can find because already we know the value of a is 1. So put s is equal to 0. So if you put s as 0, on the left it is 1 is equal to a multiplied with s squared. So this is 0. 2s. So this is also 0. So this constant 2 will come. Plus this bs becomes 0. So you will have only c. And c is multiplied with 0 plus 1, which is 1. And so you get 1 is equal to 2a plus c. But what is the value of a that we have got? We have got it as 1. So if you substitute 1 here, you will be getting 1 is equal to 2 into 1 is 2. So 2 plus c. So from this, c will be equal to, taking this 2 to the other side, you get 1 minus 2. And so the value of c will be equal to minus 1. So we have obtained the value of c. Next we have to obtain the value of b, for which we will compare the coefficient of the highest degree term. Now here the highest degree is 2 only, that is s square is the highest degree term. So we will compare the coefficient of s square. So comparing the coefficient of s square on both the sides. So here if you see, there is no s square on the left hand side, and so the coefficient of s square is 0. So on the left it is 0. That is equal to, on the right, in this first term, s square is over here. So when you multiply this a with this s square, you will have the coefficient of s square as capital A. So let me write that. So that we have only one s square term over here. Next we will move on to this. In this, the s square term will be multiplying bs with s. So this first term, so it will be bs square, and so its coefficient will be b only. So plus b. So we get a plus b to be equal to 0. So from this we can substitute the value of a. What is a? A is 1. So a is equal to 1 plus b. So from this we get the value of b is equal to minus 1. So therefore we have obtained the value of a, b and c. Now we shall take each of these values and substitute in this. That is, we will take this as equation 1. So we will substitute in equation 1 now. So in this equation 1, I am going to substitute a equal to 1, b equal to minus 1 and c is equal to minus 1. So when we do that, if we put a as 1, you will be getting 1 divided by, so 1 divided by s plus 1. And then here you have to put b as minus 1. So plus minus 1 multiplied with s, and you have c also as minus 1. So minus 1 divided by, in the denominator we have s squared plus 2s plus 2. So we will write that s squared plus 2s plus 2. Next step is we have to take inverse Laplace transform on both the sides. So let us do that now. So on the left, inverse Laplace transform of the left hand side. So whatever is there, it has come inside the bracket, and that is equal to the inverse Laplace transform of the first term will be L inverse of 1 by s plus 1. And here minus 1 is, and minus 1 is in common. So you take the minus out. So you will have L inverse of s plus 1, because both the minus have gone out. So you will have s plus 1 divided by s squared plus 2s plus 2. Now we have to find the inverse Laplace transform of these two terms. This is very easy, as we have the formula, which is inverse Laplace transform of 1 by s plus a, and that is equal to e to the power minus at. So that we can easily do. But for this, what we have to do, you can see that in the numerator you have s plus 1. So you can use the shifting property, for which the similar type of term you should have in the denominator also. For that, we are going to make the first two terms, that is s square plus 2s, as perfect square. So how you will do, you just take this s square plus 2s and write separately. So s squared plus 2s. Now in order to make this perfect square, you can see that this is like a square and this is like 2ab. So what term you have to add and subtract in order to make it a perfect square? So if you see, this is a square is equal to s square, which means a is equal to s. And here you have 2s. So 2a you have, which means the value of b is 1. And this has to be, the formula will be a square plus 2ab plus b square, so that you can write it in the form a plus b the whole square. So b is what? 1. So when we compare this, this is 2a, because a is s, and so b is 1. So you have to add and subtract 1 with this. So this will be 1 squared. So this term can be written as, I will write here, s plus 1 the whole square minus 1. So these two terms, okay, separately I have taken and I have made it a perfect square, and I have obtained it as s plus 1 the whole square minus 1. And this plus 2 we have, which we when we add with this term, we get the denominator of this term. So if I add that plus 2 over here, what it will be, minus 1 plus 2 will give us plus 1. So s plus 1 the whole square plus 1 we have as the denominator. So instead of s squared plus 2s plus 2, we have to replace it by, so we have to replace it by s squared plus 1 the whole square plus 1. Go through these steps patiently and very carefully in order to find the perfect square, and then simplify the whole denominator. And so the right hand side will be equal to inverse Laplace transform of 1 by s plus 1, and then minus inverse Laplace transform of this term. In the numerator you have s plus 1, and in the denominator this complete term has been changed as s plus 1 the whole square plus 1, so that we can use the shifting property over here. So what does that shifting property say? The shifting property for inverse Laplace transform says that the inverse Laplace transform of f of s plus a, if you have a function where a is added to s alone, here if you see s plus a is 1, so here also s plus a. So the inverse Laplace transform of a function will be of this function will be equal to e to the power minus at, because you have plus here it will be minus at, and with that you have to find inverse Laplace transform of f of s. So this is sufficient. So I will take this term separately and I will show you. So here we have to find inverse Laplace transform of s plus 1 divided by s plus 1 the whole square plus 1. So this will be equal to, now s plus a, if the function has s plus a, wherever s you have, a will be added with it. Now here the value of a is 1, so s plus 1, and this is s plus 1. So this will be equal to e to the power minus a is what? 1. So minus t inverse Laplace transform of, without having that a with s, we should write as s by s squared plus 1. So that is the meaning for this. Okay, so this function, this s plus 1 divided by s plus 1 the whole square plus 1 will be equal to, the inverse Laplace transform of this will be equal to e to the power minus t, and inverse Laplace transform of s by s squared plus 1. For this the formula is, so we have to use this formula, that is inverse Laplace transform of s by s squared plus a squared is equal to cos at. Now in this the value of a is equal to what? Again 1. So it will be cos t. So this will be the answer for this particular term. So therefore this L inverse of s plus 1 divided by s plus 1 the whole square plus 1 has been evaluated here, and it is equal to, so this will be equal to, we have e to the power minus t multiplied with the value of this. But what is the value of this? Cos t. So e to the power minus t cos t. So we have evaluated this alone separately. And for this we will be using another formula, that is inverse Laplace transform of s by, I mean not s, so it is 1. So 1 divided by, so 1 divided by s plus a. So this formula we have to use, which is equal to e to the power minus at. So these two formulas we have to use here. So here if you see the value of a is what? Now here, that is here the value of a is 1. So what about this? This will become L inverse of 1 by s plus 1 is equal to, at the place of a we have 1, and so here the answer will be e to the power minus t. So the first term is e to the power minus t, that is for this term we have e to the power minus t, and for this term we have evaluated here e to the power minus t cos t. Substitute these two values here. So on substituting we get, so at this place we should substitute e to the power minus t. So e to the power minus t, and then we have minus over here. So minus, this value has to be substituted, e to the power minus t cos t. Now in this e to the power negative t is common, so it can be taken out, and so you will be having 1 minus cos t. So this is the solution. So hope you have understood this problem. This is a little different problem, and all these steps you have to do very carefully. So kindly go through it patiently so that you will understand it more better. Thank you.